structural isomer is not a stereoisomer. It's just a constitutional isomer is not a stereoisomer. It's just a structural isomer, where you're just changing the connectivity. That's what a constitutional isomer is. A constitutional isomer is when you change the connectivity in the atom. I'm looking for my pen. I don't know what the hell it is. I don't know where the color. I need the color purple and the color green. So the color is this. That's green. Where's purple at? Okay, here's purple. Okay, so we're going to put the purple back in here, of course. This is where it was originally, for C. And also, we're going to put that hydrogen in there, and that's our iodide still. And up here, we still got this dash, this solid hydrogen. And we still, I meant to make that green. That was supposed to be green. Okay, imagine this hydrogen being green. Okay, we're going to put the dash nitrogen right there. We're going to put an H2. Now, this is the thing. This is the very important part right here. Okay, so, and of course we know originally we found that this is SS, the configuration, the stereochemical configuration. So those two carbons, right? Let's focus specifically on these. Let's make these. Let's take this, these two carbons right here to make our constitutional isomer or our structural isomer. So let's make our constitutional isomer. Now, the way we're going to go about doing this is I'm going to do this. The very definition of a constitutional isomer is if you take the original of a compound, what you're going, and of course you know, anytime I explain these isomers, I always go from the original. And this is our original right here. Original. Okay, so we're going to take the original and we're going to turn it into a constitutional isomer. To do this, all we have to do is change the connectivity. And what I mean by connectivity is I'm going to take, if this is carbon A, this one right here, and if that was carbon B, that one right there, what I'm going to do is just switch some stuff that's on carbon A and put it on B, and take some stuff off B and put it on A to make a constitutional isomer. I'm changing the connectivity. Or I'm going to take I and put it on A, and I'm going to take the nitrogen, the amine group, functional group, and I'm going to put it on B. Or better yet, I'm just going to take this one and just put it down here. I'm just going to keep it simple. I'll take the green one, because if you change any connection of any one atom in this molecule that changes the IUPAC name, that's creating a constitutional isomer. So I'm going to take that and put it right there. So so let's do that. So if I make this into a constitutional isomer, it's going to be this thing right here. It's going to be this right here. It's going to be, purple. Purple will be first. It'll be purple. That'll still be right there because I didn't move it. I decided not to. And then I'll put this right here. Notice how I got that nitrogen right there now, NH2. But it was not right there previously. And this is the same B right here. But of course, it has different chirality now. That's still a chiral carbon, don't get me wrong, but I don't know if it's RS because we changed the priorities. Okay, so now what we did was we put that pink hydrogen up there, and we kept the green one. Remember I told you, even though I drew it black, I made a mistake. It's really green, just like this is, like it was in the previous drawing. So we're going to put the green one, or we're going to keep the green one up here. We never removed the green one, right? This carbon now is not chiral. And the reason this carbon is not chiral is because it's connected. Anytime a carbon is connected to two of the same things, it's not chiral. And it's connected to two hydrogens, so it's not chiral. Also, anytime a carbon is in a double bond, it's not chiral. Anytime a carbon is in a triple bond, it's not chiral, because that carbon, it's impossible for it to be connected to four things, because it can only be connected to less than four things if the carbon is in a double bond or a triple bond. So these are also useful things. Okay, so we finally finished this problem, and we figured out how to draw the constitutional isomer of this compound right here. We figured out what the R and S configuration was. And until next time, if you want to get good at this class, or this subject, you got to practice, practice, practice.